and then the speaker will talk, and they will sit back, and then will come join. There might be
So live started.
Like started?
Yeah.
No, but we will
YouTube.
record in Zoom and that will be
That
directed
is
to here, right?
that is-
Both are same.
same.
Simultaneous.
Zoom recording with live. That is.
This is, you require any OTP, any password?
No, I just
No.
logged in.
This is log.
ready.
This is logged in. This is live. We'll copy.
That is also, poster will go, share screen as a poster. Okay. So, CK. Oh, it is there, right? So you kept it in loop. Very good. And
No,
this is
it
a
won't.
never ending loop, right?
It won't because in people. You can put translation.
Automatically it will change, right?
No, once we switch on the camera, it will not go. It will stop.
Camera means, no, switch on the
Zoom
camera.
camera. Once you switch on the Zoom camera.
Switch
Loop
on.
continuously until I escape.
But we can share screen, right? Share screen is there.
Yeah, that time span.
You can check. No, you can do.
So Manish, now share screen is there.
Yes, sir.
Zoom camera is on.
Yes, no, Zoom camera is not on.
On.
So sort of we need to take for say PPT here.
Just got national science day.
Can you share the screen, please? Like the PPT. Of this national service. Okay, thank you.
Hello, 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 hello.
Few of the places for the Arunachal students, they have gone out. So please ask them to keep those places like free so that they can sit. Also, the live streaming is going on in PC2. So if it fills in, just send them in other place. Yeah.
Can you please ask the coordinators to be there after you? Coordinators को बोल देंगे कि भेज दे like to VOS को because yeah.
कुछ तो
आर्या और तो ही बोल दो. There are more people to come.
How do you connect here?
Yeah, live stream also.
That's okay. How do you connect here?
It's connected with the live stream. So all the cameras and all those things has to one with this.
Okay, so but you cannot connect it to now, is it?
Copy the slides.
I can give you a slide, but it may not work. That is why. Just want to check.
We have extras here. Can you
I give you the mic.
Sure.
Okay.
That's why I'm saying this. Because don't forget to put this up.
Okay.
Let's say something that will be.
Okay. Sir, sorry, Pranjit. Natarajan sir is calling. Sir is calling.
I just want to check.
Okay. You sure.
Six zero six. Yeah, it's on. Just put it outside.
Before inviting sir. They will. Their names.
Pranjal, we can change instead.
That the director sir wants. He wants to do this themselves. So after you say that, can you please right now invite?
Project it there.
Okay.
Once we start or now we have to start. Please.
What? Once you video, can you go to the end? Yeah, open it will be a problem. You'll be projecting it here.
Yes, sir. Then okay, then we will.
Not fair. Yeah.
I now I would like to invite.
It's coming.
Here, before that. There is a video.
Okay. Okay, we can click it, it will come. If not, we will play from the.
One slide up. Here is a video. You will not just see whether that is playing. So. I'll be playing something.
This is slide.
Sound is okay now. There is no problem. Just pull out the.
Extra money.
Yeah, 1 minute.
Okay. We will pass.
Back in.
Start from here and then go.
Okay, okay. Now I would like to request the students from Arunachal Pradesh to kindly introduce themselves.
Introduce means promotion gets be done. Quickly name and place. Then introduce themselves by calling their name. And
Yes.
is it share?
Quickly.
Please now. Amish, can you do it? Because it's this is the host, so you just make it permission.
Quickly.
But they'll upload, then we can participate. Check in the computer, whatever. They call a co-host. All of them are hosts. National time. So you can record it from here?
No, sir. No, not really. It's probably only Zoom one, sir. Stop. But we are the only host.
Yeah.
But I
National Science Day. That's
record.
So the students. Yeah, they are talking here. They haven't. Yes.
It's not recording. It's recording.
This is on live.
That is YouTube, sir.
The moment is there, so just after.
This is record. Please ask the host to give you permission to record.
You're the host.
Yeah. Check go there.
Not registered.
Participants.
So that's after 11.
Here on the
Department.
director sir is there. Maybe director sir to give it. Otherwise, I will.
You are somewhat connected. You're logging.
I think so. You log out from, if you log out from here, you can log in again and be a host. Do it.
And
Not only to me,
No,
after this.
Okay, I will just. No idea.
tell him to record from cohort or somebody from there.
Yeah, I will just tell him to give me a vote access. Why he made me. Naidu, can you make this National Science Day IIT Tirupati as a host? Because those two systems are becoming host and co-host, we cannot record. Yeah, make it host. Okay. All of it. Where are the other two who are logged in? Who is there? If you log out and log in, then it is possible. Okay. Yeah. Yeah, can Naidu, you logged in? Yeah, just make it host. Make me host. National Science Day IIT Tirupati, make it host.
He can record something.
What's that?
Yeah, he can record.
Oh, we will record here. Yeah, yeah. Department of Chemistry is host. Who, from where you logged in?
Who is this? This one?
I don't know who are these guys are like logging in. Yeah.
Hello.
What is using? Log out and log in. I have that.
I am the co-host. I am the co-host. So I cannot make me host. So I am the department. They want national science is the host.
Yeah, reclaim host.
Department host.
Right? Live is on, right? Yeah. Check live YouTube is live and
আমাকে বললে বলবো ওখানে বিজি আছে
mute all.
Yeah, sure. 93.
Asked to mute.
PSC candidate no understand.
Okay, relax.
उत्तरम यस् समुद्रस्य हिमाद्रैश्चैव दक्षिणम वर्षम तद भारत नाम भारती यत् संतते. The country that lies north of the ocean and south of the snowy mountains is called Bharata, for there dwelt the Bharatiyas.
A very good morning to everyone. This is Malvika,
And this is Pranjal.
and we will be your hosts for today's proceedings. Arunachal Pradesh, the land of the dawn-lit mountains, located on the northeastern tip of India, with its borders touching China, Bhutan, and Burma, it is the first Indian soil to greet the rising sun. It is our great honor to welcome today guests from Arunachal Pradesh to the beautiful state of Andhra Pradesh.
India is a unique nation, embedding unparalleled excellence in her linguistic, social, and cultural core, symbolized through the quintessential national identity fabricated around the tenets of justice and nonviolence. The spirit of mutual understanding of a shared history is typified through the maxim of unity in diversity, which exemplifies the spirit of nationhood that needs to be cherished and fostered. The idea of a sustained and structured cultural connection between people of different regions was mooted by Prime Minister Shri Narendra Modi during the Rashtriya Ekta Divas held on 31st October 2015 to commemorate the birth anniversary of Sardar Vallabhbhai Patel. Ek Bharat Shresth Bharat program aims to enhance interaction, celebrate cultural diversity, and promote mutual understanding between people of different states and union territories. The states carry out activities to promote a sustained and structured cultural connection in areas of language learning, cultural traditions, and music, tourism, and cuisine, the sharing and celebrating the best practices harbored by their communities.
India, being a nation with one of the youngest populations in the world, an initiative of Yuva Sangam under Ek Bharat, Shresth Bharat has been conceptualized with the goal of strengthening the people-to-people connection and building empathy between the youth of the northeastern states and other states. The Yuva Sangam will focus on conducting exposure tours of the youths comprising mainly of students studying in higher educational institutions and some off-campus youngsters from northeastern states to other states and vice versa. It will provide an immersive experience of various facets of life, development landmarks, recent achievements, and a youth connect in the host state. Similarly, students from the higher education institutes of the northeastern states will visit higher education institutions in other Indian states for a similar experience. During their visits, the youth will have a multidimensional exposure under 5 broad areas: Paryatan, that is tourism; Parampara, that is traditions; Prakriti, that is development; Paraspar Sampark, that is people-to-people connect; and Praudyogiki, that is technology.
Ek Bharat Shresth Bharat aims to promote the spirit of national integration through a deep and long-term engagement between the states. It seeks to showcase the rich heritage and culture, customs and traditions, and diversified spirit of states, thus enabling people to appreciate the diversity of India by nurturing a sense of common identity. The program also intends to make people aware of the seamless integral hull of modern Indian states that is spread across a vast landmass on whose firm foundations the geopolitical strength of the country is ensured to benefit one and all.
The cultural, linguistic, social, and culinary fabric of our country has always been rich and diversified. But we have always been one civilization and one truth incarnating in various forms. And what better time to weave together these forms in the age of information and connectivity? Our passion and inquisitivity towards nature and its exploration can become a strong strand in the thread that binds us together. And therefore, we decided to combine National Science Day's proceedings with Ek Bharat, Shresth Bharat to celebrate our diversity and underlying oneness. And for this momentous occasion, we are humbled by the presence of our esteemed director, Dr. K. Satyanarayana, filling the aura with his infectious curiosity, Professor T. Natarajan, and our keynote speaker of the day, Padma Shri Professor T. Pradeep.
So let me tell you a story of a genius scientist, a man of many conflicts, the quantum Indian, Dr. Chandrasekhar Venkat Raman. Dr. C.V. Raman was an assistant auditor general for the government of India in Calcutta. When he came across Indian Association for Cultivation of Science, the place funded by an Indian zamindar and physician had a great library and modern labs. Dr. Raman started working in the labs in the mornings and soon published erudite articles in Nature and other reputed journals on vibration in strings, light in crystals, and many more. He was struck by the deep blue Mediterranean Sea on his voyage to Europe, and thus began the exploration on scattering of light. He wrote to G.D. Birla to fund a spectrograph to validate his findings and promised a Nobel Prize within a year. Skeptic that someone else might publish this first, he sent his findings via telegram with all the equations and spectra. He sent his paper to many Nobel laureates, including Rutherford, Niels Bohr, and many others, asking them to recommend his name for Nobel Prize. On top of that, he called a press conference on 28th of February 1928 to further his claim for Nobel Prize, which is why we celebrate National Science Day on 28th of Feb. While receiving the Nobel Prize, he cried on the stage when he realized that everyone had their national flag on their chair, but there was British Union Jack on his. He couldn't claim to come here as an Indian. In his official speech, he dedicated the Nobel Prize to the freedom fighters, spending the prime of their lives to free the nation from bondage. Dr. C.V. Raman is a symbol of both our scientific heritage and deep devotion to the idea of India. And that is why we decided to combine the orientation of Ek Bharat, Shresth Bharat with National Science Day.
Now, I would like to request the students from Arunachal Pradesh to kindly introduce themselves with their names and place. We can start it from there. Yeah.
Good morning, everyone. My name is Kyoda Rima. I'm pursuing my BTech in the Department of Electrical Engineering from IIT Arunachal Pradesh. Thank you.
Good morning, everyone. My name is Priyang Otan, and I'm pursuing MSc Geology in RGU, Arunachal Pradesh. Thank you.
Good morning, everyone. My name is Ms. Kenbi Riba, and I'm currently pursuing my BTech in Civil Engineering from NIT Arunachal Pradesh. And I've been born and brought up in a really beautiful place called Basar, which is in Leparada district of Arunachal Pradesh. Thank you.
Good morning, everyone. My name is Miss Jasrul Simai, and I'm doing my master degree in botany in Rajiv Gandhi University, Arunachal Pradesh. Thank you.
Good morning, everyone. My name is Mikan Mosang, and I'm a fourth-year BTech student in the Department of Mechanical Engineering. And I have been doing my education in Arunachal itself, in different parts of and in different districts. Thank you.
And all, my name is Sring Chukla and I am from Menchukwashi, Yoma district, Arunachal Pradesh. And currently I am pursuing electrical engineering from NIT Arunachal Pradesh. Thank you.
Good morning, everyone. My name is Nivya Kappa. Currently, I'm pursuing my PG diploma course in Geoinformatics Science in Rajiv Gandhi University, Arunachal Pradesh, and I'm belong from Papumpari district and NEC tribe from Arunachal Pradesh. Thank you.
Brothers and sisters, myself Asna Panging from NIT Arunachal Pradesh. Currently, I am pursuing my BTech degree in civil engineering from NIT Arunachal Pradesh itself, and I belong to Adi tribe from Upper Siang district. Thank you.
A very warm good morning to one and all present here. My name is Miss Anjali Muza. I'm currently studying in Rajiv Gandhi University, Arunachal Pradesh, pursuing my MSc in the field of geology. I belong to a lovely village, Riga, situated in Siang district, Arunachal Pradesh. Thank you.
Good morning, everyone. My name is Tamrija, and I'm pursuing my BTech in the Department of Civil Engineering from NIT Arunachal Pradesh. And I belong to Nishi community, which is a very beautiful and major tribe of Arunachal Pradesh. Thank you.
Good morning to everyone. Myself, Polly Kipa, and I'm currently pursuing my BTech in the Department of Civil Engineering from NIT Arunachal Pradesh. Thank you.
And I would request the faculties, the honorable faculties from Arunachal Pradesh and the faculties accompanying the school students also to introduce themselves, please.
Namaskar. My name is Dr. Ramprakash Sarma. I am the faculty member of Department of Mechanical Engineering, National Institute of Technology, Arunachal Pradesh. Basically, I belong to Rajasthan, Jaipur. Namaskar.
Good morning, everyone. Myself, SN Deepa, Associate Professor, Department of Electrical Engineering, NIT Arunachal Pradesh. It's nice to be here for this event. Thank you.
Good morning, everyone. My name is Dr. Nabam Rich. I'm working in the Department of Civil Engineering and as an assistant professor, and I'm very happy to be here seeing all of you. Thank you.
Good morning, everyone. I'm A. Vanav Kumar. Basically, I'm from Madurai, Tamil Nadu, working at NIT Arunachal Pradesh, Department of Mathematics.
Good morning to everyone. I am Haridharan, currently working as assistant professor in the Department of Civil Engineering. I am from Tamil Nadu. Okay.
School teacher. School teacher.
A warm good morning to all of you. Myself, Dhanya Anish. I'm from KV Venkatagiri. I'm working as social science teacher there. Thank you.
Good morning, everyone. My name is Dr. Sunil Kumar Yadav. I am Sanskrit TGT, Kendra Vidyalaya, Venkatagiri. Thank you.
Good morning, everyone. My name is Manu Prakash Maurya, and I am working in Kendriya Vidyalaya Venkatagiri as a PRT music. I belong from Varanasi, Uttar Pradesh.
Good morning, one and all. Myself, P. Venkatlakshmi. I'm working as a PGT Physics. I'm coming from Venkatagiri. Thank you.
Good morning to everyone. Myself is Madhavi. I am working as a TGT Maths in KV Venkatagiri. It's nice to see.
Good morning, everyone. I am S. Jabin from Bharati Vidya Bhavan Tirupati. I am TGT Science, a science teacher. Thank you.
Namaste, everyone. I am Vijayalakshmi Damaraju from Bharati Vidya Bhavan Tirupati. I am working as a science faculty, at the same time Innovation Lab in charge. Thank you.
Good morning, everyone. My name is Sivashankaraya. I am working as a PGT Physics. So 25 students are accompanied from my school BVBs.
Now, I invite our esteemed director of IIT Tirupati, Professor K. Satyanarayana, to impart his wisdom to brilliant young minds. Sir, please.
So good morning, everyone. So I join my colleagues and our students here at IIT Tirupati in welcoming you all to IIT Tirupati and to the state of Andhra Pradesh. The initiative that our Ministry of Education, in association with a number of other working. Oh, that's not working. Hmm? Yeah, it's all the way to the top. Okay.
No, it's fine.
Is it audible?
Yes.
Yeah. Good. Very good. The initiative Yuva Sangam that the Ministry of Education, Government of India has put together under the Ek Bharat Shresth Bharat initiative is a great initiative to bring students from across India, various states together, meet with each other, understand the various aspects of the country, whether it's from the perspective of cultural traditions, development, what kind of industrial development is taking place, what kind of scientific development is taking place, what kind of economic development is taking place across the country. In fact, earlier IIT Tirupati, IIT Tirupati was linked up under the Ek Bharat Shresth Bharat program with Punjab. We were trying to create events across Punjab. But the new initiative that the Government of India has taken, a very welcome initiative on a Northeast program where they are, I think they have a plan for a very large scale interaction between the students between Northeast and the rest of the country. And this is the pilot phase. This is the first phase that they've started off by identifying 14 institutions to coordinate interaction between the Northeastern students and the students in other parts of the country. So from Andhra Pradesh, they have chosen IIT Tirupati to be the coordinating institute in association with NIT Arunachal Pradesh in Arunachal Pradesh to create this interaction program. And we are very thankful to the ministry for choosing IIT Tirupati as the coordinating institute. This was done in a very fast mode. The whole initiative started about less than a month back in putting it together. And it's amazing that they managed to pull it off with multiple ministries coming together, Ministry of Education, Ministry of Culture and Tourism, Ministry of Youth Affairs, Sports, and so on. And then with the association with IRCTC to take care of the logistics and so on, and the institutions that have been identified to take care of it, and the various other government entities in making it happen. Initially, the plan was that all of you should be traveling by train between here and there, right? And the country is a vast country, so you would have probably passed through about 8-9 states or even more before you reached here if you came by train. But then it was a grueling journey. We found that there is a train. Actually, there's a train that starts from here, Renigunta, and comes to your state, all the way state. It comes to Dibrugarh. Takes 56 hours of travel. So that gives you an understanding of the length and breadth of our country, 56 hours of travel. And then we were told that after we get off there, to get to the NIT Arunachal Pradesh campus and where our students were going to go stay there is another 5 hours travel, right? And given our trains, sometimes they get delayed for various reasons. And I was told that this train usually probably gets delayed over 4 or 5 hours. So you're talking about 65 hours or so travel, right? So we made a case to the ministry that this would really be tiring and grueling. So I'm very thankful to the ministry for government for considering our request and making a provision for air travel to come here. So obviously the government has certain policies, but when you have a proper reasoning and a proper basis, they always are willing to look at it in a very positive way and make things happen. We have put together a very interesting program for all of you. How many of you are visiting Andhra Pradesh for the first time from Arunachal Pradesh? First time. Oh, okay. How many of you have never visited Andhra Pradesh? I'm sorry. How many of you have visited earlier, Andhra Pradesh earlier? Oh, 2 of you, 3 of you visited Andhra Pradesh earlier. Okay. So this is not the first time for everyone, but except for 3 of you. So we are trying to give you an exposure of various aspects. I think there's a much greater briefing later on what you'll be covering. All of you would have heard of Tirupati for its temple town, being a temple town, right? It has one of the most visited temple in the world. the Lord Venkateshwara temple up in Tirumala, up the mountain, which is probably also considered as one of the richest temples also in the world. And on the average, on a very lean day, they have at least 50,000 visitors. On a weekend or minor festival days, maybe 100,000, 1 lakh visitors. On a major festival day, about 2 lakh visitors. Okay. So on the average, there are at least 70, 80,000 pilgrims visiting the temple every day. So everyone knows of Tirupati because of its association with this particular temple. And there are other temples, many number of other temples around, not only from a religious perspective, from an architectural perspective, you can look at them. You can look at them. They use only natural colors and dyes, and it's an amazing process that they go through. You know, the paintings that are made go through a process of the dyes have to get hold steady fast with the cloth for decades, if not centuries, right? So how does that process happen? They will show you all that today. They take about 10 days to two weeks to complete the whole process. There's a major initiative the government of India has already also taken on the Indian knowledge systems. We have our Indian knowledge systems date back thousands of years, and putting them on a scientific basis. So one of IIT Tirupati has a center under the Indian knowledge systems, one of which under the center there are about 3 initiatives, one of which is to study the kalamkari art, the chemistry of the paints, how are they working, what is the process they're going through, and so on, and putting them on a scientific basis. So that's one visit you're going to be making. So you'll also be visiting a kalamkari art center and visiting the Kalahasti temple. Then you have a visit to tomorrow morning. You have a visit to the Lord Venkateshwara temple. Okay, that is when anyone coming to Tirupati feel that their visit is incomplete unless they visit the Lord Venkateshwara temple. And there are a lot of people, there's a belief that the Lord has to invite you to come and visit. They call it bulawa in Hindi, right? Unless you get that bulawa, you don't get a chance to visit. So all of you got the bulawa. So that's how you are here, and you're going to be visiting the temple. And everyone who comes to IIT Tirupati, first request is, can you arrange the visit to the temple, right? So you're very fortunate to get that privilege. We've talked to the Tirupati, Tirumala, Devasthanam people, and they're given special permission for your visit. Okay, so you're very, people will think that you're really fortunate to have that privilege. That is this part of the religious, cultural part of this part of this part of the country. We're also, Tirupati is also becoming a big knowledge hub, educational hub. It's a town, Tirupati town, which is about 20 kilometers from here, 25 kilometers to the center of Tirupati town, has a population of less than 4 lakhs, about 3.5 lakhs population, but it has 8 universities. 8 universities. 3 of them are central university institution, the premier technology institution of the country, which is IIT, the premier science institute of the country, which is ISER, Indian Institute of Science, Education and Research, It's in Tirupati. It's just 3 kilometers down the road from here. And we have the National Sanskrit University, okay, which now become a central university. So 3 central universities. The number of few state universities. Sri Venkateshwara University, which was established in 1959. Then we have one of the leading women's university in the country, Sri Padmavati Mahila Vishwavidyapitam. And then we have the veterinary university of the state located here. The agriculture university has a very big campus here. Rockets and satellites are launched from. So we've arranged a visit to Sriharikota. I don't know, on the day you go, there may not be a launch, but at least you'll see the facilities that have been created there. It's about 60-70 kilometers from here. And near that, around the area around Sriharikota actually is an island just off the coast, connected by a bridge, small bridge. There's a beautiful lake called Pulikat Lake, which attracts a lot of migratory birds. Of course, the peak season is in January, February. Now the season is sort of dwindling down. So you'll get an opportunity to visit the Pulikat Lake to see some birds and so on. Those of you who are interested in bird watching. In fact, our campus by itself, we have this regular bird watching camps that we keep running. We have 210 bird species visiting our campus. We have documented all this. We have colleagues from ICER who specialize in ecology and in study of birds and so on. And we've been tracking this, and we've documented 210 varieties of birds, including coming from Himalayas and from Siberia, the migratory birds that come here. So our campus also has been getting a number of these. Then we have interactions with various universities. And then we have a visit to Sri City. Sri City is one of the biggest private technology parks, industrial parks in the country. It's actually Sri City, you'll have again go through Kalhasti to reach there. It is a 10,000-acre private industrial park, which has about 120 companies which have set up shop from all over the world. There are about 30 Japanese companies which have set up the shops. Isuzu trucks in the country are made there. The metro trains, we have metro trains being implemented in various parts of the country. So the metro trains for the Chennai Metro, for the Cochin Metro, and Sydney Metro, Australia, Sydney Metro, they're made in Sri City. Alstom has set up its factory there. So the metro trains are made there. Cadbury's, now it's owned by a company called Mondelez. I'm sure everyone has eaten Cadbury's chocolates. They have a big factory there, 100-acre factory, completely automated. If you watch some of these movies, some Discovery Channel and National Geographic channels on large factories where everything is automated. That factory has that. We have companies like that. We have companies like VRV, which makes cryogenic storage tanks, from small tanks to rockets requirements, and so on. So this is where I arranged a visit to that, so that you also get an exposure, the kind of industrial development that is taking place in this country. And we also arranged a cultural evening tomorrow. The Honorable Minister for Tourism and Culture of the state of Andhra Pradesh, Mrs. Roja, will be here. and they've arranged a small cultural event for you to see the traditional dances and music and dance in this part of the country. And one day evening, we are also going to Tirupati. Also has the Indian Culinary Institute set up by the Ministry of Tourism. So they're going to be hosting a dinner for you to give some of the traditional food. Okay, so I hope all of you will enjoy, experience, and learn from this experience, and build strong relationships with this part of the country also. And at the end of this day, based on these interactions, we hope that you will create that bond. In fact, in our institute here, we have students from 22 states, including from a number of northeastern states. We have had students from Arunachal Pradesh. I don't know if the student is still there now. I think she's there. One of my students in one of the class was from Arunachal Pradesh. So we have students from a number of northeastern states in IIT Tirupati. So we are looking for more of you coming here as students as we go forward. And we are very fortunate today. And also our campus. I have to tell you a little bit about our campus. We're also a new institute. Many of you I've seen are from NIT AP. There's also an NIT AP in Andhra Pradesh. Okay, they also call themselves NIT AP in Tadepalligudem. Okay, a town called Tadepalligudem, about 500 kilometers from here. There is an NIT Andhra Pradesh. So this institute was started in 2015, right? Your institute, I think the NIT is started, I was told, started in 2010, right? So NIT Arunachal Pradesh is 5 years older than us. But we are one of the fastest growing institutes in the country in terms of the rate of growth, whether it is from building our campus, faculty recruitment, student recruitment, so on. So at IIT Tirupati today, we have 1,450 students, out of which 250 students are PhD students. And we have BTech programs and 5 branches: civil engineering and civil and environmental engineering, electrical engineering, mechanical engineering, computer science and engineering, and chemical engineering. And then we have MTech programs in all these areas, various streams. We have MSc programs in math, physics, chemistry. We have a master's program in public policy offered by our Department of Humanities and Social Sciences. And we have PhD program in all the 9 areas. In fact, we have PhD students starting from chemistry to philosophy. Okay. Our humanities department is also very active. We have PhD students in literature, philosophy, and of course, all engineering areas. And we've been very active in research. We have about 130 sponsored research projects to the tune of about 170 crores. So, our campus is being built on a 548-acre campus. So please enjoy the campus, walk around. Okay, you will see the new construction that's going on, and we will see that we have workers on our construction site. We have nearly 2,000 construction workers working on our construction site, and 90% of our workers from other parts of the country. We have people from mostly from Jharkhand, Chhattisgarh, Orissa, West Bengal, even some from, I think, Assam, Punjab, and so on. Again, that's a big, Ek Bharat, Shresth Bharat initiative. You see, we have people coming to build our campus. Okay, so out of right now, what we have built so far is the first stage of our campus, what we call the stage 1, which caters to about 1,500 students, about 100 faculty members, facilities for them, and so on. And next end of this year, we're going to start building the stage 2. So whatever you see here, if you come back after 3 years, there'll be double the size buildings of what you see here. Okay, so please go around also and see the campus, enjoy the campus, and have a great stay. And we'll continue to interact over the next few days. Anything you need, our team from here is there to work with, to help you, to take care of you. Please feel to reach out. And I'm really thankful to my team here led by Professor Dr. Vanit Kashyap, who is the faculty in charge of the Ek Bharat Shresth Bharat initiatives. They've been working extremely hard, doing all this in such a short time, keeping on following up. Then Dr. Vibhuti Meri Kashyap, and then Mr. Chaman Mehta, Mahesh. These are the lead, but then a whole bunch of other people have worked very hard, including our student volunteers. Please interact with them and let us see what if you need any concerns, if you have any help you have. We are putting up in our student hostels, so that you will have an opportunity to interact with our students, other students. So please reach out, and I request our students also to create opportunities for interacting with them, and they having a great experience here, right? And we are very fortunate today to have in our midst one of the leading, most celebrated scientists in the country, Dr. T. Pradeep from IIT Madras, Padma Shri awardee, Bhatnagar awardee, and Professor of Chemistry. If I have to list all the awards he's got, it will take us another half an hour. One of the most celebrated chemistry scientists in the country. So we are very happy to have him here. And I'm also very glad that some school children also have joined, especially because of the Science Day. We were planning to have an event for the Science Day for school children. So we thought it's an opportunity for all of you to work together. And I'm sure they will be introducing Professor Pradeep, so they will give his more detailed biodata. So thank you, Professor Pradeep, for accepting our request. In our midst, we also have Professor T.S. Natarajan. Professor T.S. Natarajan was Professor of Physics at IIT Madras, and then was also Professor here at IIT Tirupati for a number of years, helped establish our institute, and very passionate about taking science to the schools and the masses. So he has been doing a number of initiatives. He has come up with a number of kits that schools could use to teach various science principles to the children. So he's here. He's going to do a session also today afternoon. Unfortunately, I think the Arunachal Pradesh students will miss that session because they have to go see the temple. But the other school children will have the opportunity of interacting with him on this platform. So thank you both for accepting our invitation and being here today. And finally, I would like to once again thank the ministry for giving this opportunity for this very important and required initiative that they brought forward, and we look forward to continuing to work on these things. Thank you very much. Yeah.
Thank you, sir, for such a welcoming session. I'm sure that you have made all our guests feel welcome and excited for the upcoming visits.
Now I'd request to invite Dr. Saurav Chakravarti to introduce and invite the Honorable Chief Guest and Keynote Speaker of the day, Padma Shri Professor T. Pradeep, IIT Madras.
Good morning, everyone. Today we are celebrating the spirit of National Science Day to mark the discovery of Raman effect by Sir C.V. Raman on 28th February of 1928, who was awarded the Nobel Prize in Chemistry in 1930. Since 1986, the National Science Day has been celebrated every year with a particular theme, which happened to be Global Science for Global Well-being for the year 2023. To celebrate the spirit of science and technology, we welcome our esteemed guest, Padma Shri Professor T. Pradeep from IIT Madras, and Professor T.S. Natarajan from IIT Madras and IIT Tirupati as well. Today, I am very pleased to introduce the speaker of this morning, Padma Shri Professor T. Pradeep. His admirable work and technological inventions inspired the younger generations in the last 2 decades. Professor Pradeep pursued his PhD from Indian Institute of Science, Bangalore in 1991 with Professor Shiana Rao, followed by postdoctoral tenures in the Lawrence Berkeley Laboratory and Purdue University, Indiana. Then he joined IIT Madras in 1993, where he is currently the Institute Chair Professor and Professor in Chemistry since 2016. He held visiting professor positions in many acclaimed universities in this world: Purdue University, Leiden University, Netherlands, EPFL, Switzerland, Institute of Chemistry, Taiwan, Pohang University and Science and Technology, South Korea, University of Hwago, Japan, to name a few. His research interests are in molecular materials and surfaces. His research group discovered the world's first nanochemistry-based water filter for pesticide removal, and his technology is esteemed to have reached out about 9 million people of this country. He also developed Amrit technology, which is being implemented now in the arsenic-affected regions of country and benefits about 1 billion people. Several companies have been incubated with the participation of IIT Madras, along with his scientific endeavors, which takes care of affordable technology to help the human race and the environment. His profound research includes developing novel materials, noble metal clusters, monolayer protected nanoparticles, surface chemistry, thin films, to name a few. He is the professor in charge for the International Center for Clean Water, IICW. To date, he has published around 800 plus research articles in highly reputed chemistry and material science journals around the world. He received several awards like Win Future Prize in 2022, Prince Sultan bin Abdul Aziz International Prize for Water 2022, Nikki Asia Prize 2020, TWS Prize 2018, JC Bose Model, National Fellowship 2015, Shanti Sharu Bhatnagar Prize in 2008, and BM Birla Science Prize and Young Scientist Award in Chemical Research Society of India 2003, to name a few. In 2020, Government of India awarded him with the Padma Shri Award in Science and Engineering for his pioneering work on material science and nanotechnology commercializations for affordable clean water. We are honored for your gracious presence today, sir, and fortunate to share the time with you. We eagerly await for exciting talk today, especially the country's young buds who are present here. Words are insufficient to praise your applause, and without wasting more time, let's welcome Professor Pradeep on stage. Thank you.
Thank you. And slide change. Yeah. Please switch off this one now. Slide changer is there, right? Yes, good. Thank you. What a great pleasure to be here with all of you. Thank you for being here. Thank you for inviting me here. Satya, my dear friend, Satyanarayana, I call him Satya, right? Our dear friend. And it is also a pleasure with TSN, TS Natarajan, we call him TSN. So all our people. And I'm especially here because of the persistence of Shihab, again, our person, IIT Madras student. It's very nice that Shihab also spent some time with me. It's when he invites, it is important to come. Although I have today my group meeting day, it was canceled to be here. When I was told about this theme, the country's unity in diversity, which we are celebrating with Yuva Sangam, I was thinking about the country. For a scientist, this country and its population, the human diversity was studied with DNA. Today, we can go back to 66,000 years. And in the 66,000 years of DNA, we have found that this country is a mix of every civilization. It is a mix of every possible DNA piece in the world. This country is that rich. And that early Indians, this is this celebrated book. Those of you who would like to know more about it, please read that. Because my theme is something else, I'm not getting into that. I will only touch upon something that is relevant in this context. In that genome, of course, many things have come here. This was a sort of a pot of mixes of DNA. Along with that, it is not just mix of DNA. It's a mix of in later years, it's a mix of spices. It's a mix of many things as Satya talked about. It's a mix of languages. I just want to touch upon one little thing. When people like you travel from Arunachal Pradesh to Andhra Pradesh, AP to AP, you also saw, well, we in the state that I am coming from, Kerala, one person traveled to Tamil Nadu, a short distance. At that time, the short distance was traveled by foot. And he went to study in Tamil Nadu. And this was a person born in 1495, whom we call as the father of Malayalam literature, Tunjathezhuthachan. Today we call him as the father of that language. Of course, all of you are aware of many, many fathers. Therefore, let me just tell you only about one father. This father became a celebrated poet because he studied in Tamil Nadu. He couldn't go there to study Tamil Nadu because there was no money to pay, money for travel, money for living. That time, one day, a person appears in front of his house. He says, in my dreams, I felt that there is a little boy here who needs my help. Fortunately for me, I have a little bit of money. I would like to help this boy. This was the celebrated Muslim trader of the region. And that trader gave his wealth to this boy for his studies and told his people that this person whom you are carrying today, you will carry him on a pallak. Take him because he is the wealthiest, most wealthiest thing that you can ever carry, because he will change this country. Well, he talked about country at that time. Country at that time meant a small region. Therefore, I'm sure that you came here and we go there. This AP to AP exchange will bring in greater excitements in the years to come. Thank you for coming. And I'm sure that you will get excited by this. I have many other things to talk about, but then I will leave those. Today, I will be speaking to you on this subject. May I have some lights dimmed here? We are celebrating Raman. We are celebrating Raman and Raman's heritage. We are also celebrating, some lights are needed on my face too. Yeah, we are celebrating science, but that science has always been and will continue to be for humanity. It is not our science, your science or my science, it is science of everyone. There is this great saying that language itself is one such thing. I'm calling you T.S. Natarajan. You know why? Because there are people around you to call you T.S. Natarajan. Otherwise, you are not T.S. Natarajan. You become you because others call you. Language becomes what it is because there is somebody to speak. And you know, it is not your language or my language. Language is actually in between. Science is also in between. And this is what was said by a great physicist, well, the one and only Newton. And Newton said that I'm standing on the shoulders of giants. Otherwise, there is no science at all. Raman was also like that. So when we start celebrating global science for global well-being, I must also tell you that science has always been global. Science has always been global for global well-being. However, there is a very important reason why we talk about this theme today. And that is why, that's what I want to spend my time on. Well, if you want to read more about, as a student, I read this book, Journey into Light, and I'm sure this is available from the academy, that is the Bangalore Academy, very low-priced book, but very thick book. And I and T.S. Natarajan enjoy an instrument called Mridangam. And you know, C.V. Raman worked on Mridangam. So C.V. Raman worked on many, many things. And it is very important to understand that this man was not the scattering person. This man was not the strings person. This man was not the veena person, not the mridangam person, not the stone person. Raman got into everything. Raman one day was in Cubbon Park. Raman went in Cubbon Park, is a park in Bangalore. And Raman used to walk. Of course, in this long coat of Raman, he used to carry a small, tiny microscope. And Raman would go near a flower and look at this flower. And one day, a journalist asked him, "Sir, what are you really looking at?" "Well, I'm looking at this flower." "But what do you see in this flower?" "Well, I see this small thing. This small thing. And then what do you do, sir?" "Well, then I imagine. The rest of it is imagination. You just need a tiny bit, and the rest of it is imagination, and that is that person." And obviously, coming here from Arunachal Pradesh, I request you to take the spirit of Raman, see a little bit, and add a lot of imagination. And all of you will get immensely motivated with that. When I talk about this theme, the first thing that came to my mind was this picture. This picture is said to be the most celebrated environmental picture ever taken. This picture was taken by a person called William Andres. As he was, well, he took this picture as from this particular vehicle, Apollo 8. On December 24th, 1968, and as it went up, in the shadow of the moon, the Earth is rising. And this is this picture called the Earthrise. There are many Earthrise pictures, but this picture made everyone realize that there is only one planet. And all our aspirations, all our hopes, and all our expectations have to be met with that planet. And this is even more profoundly captured by another great picture. That picture is called the pale blue dot. This pale blue dot was taken from Voyager, and Voyager was sent to see the solar system, to look at the solar system from a very long distance. On that day, February 14, 1990, Voyager was already 6 billion kilometers away, and it had passed the solar system. Just by the end of Uranus, and it looked back and took a picture. And in that picture, one portion of the sky was this. And that dot that you see is blue. And that dot is blue because Earth is blue. Earth is water. And in this picture, all our aspirations, as I just told you previously, they're all contained. All our knowledge is contained in that. All our inheritance is contained in that. All our love and hate and hatred and all that, all our philosophy is contained in that. So it has inspired a lot of people to think about one Earth. One Earth. And that one Earth is under threat today. And this is the central reason why we talk about global science. And what is that threat? And why should you think about this threat? And why should you, as children of tomorrow, should think about this? Is the subject that I wish to dwell upon a little bit more about it later. If you are interested in, we can talk about it. But you know, this Earth that we are talking about, this 12,600 kilometers diameter Earth that we have, is not really that Earth that we really live in. We are really talking about that tiny, thin Earth, just about 13 kilometers away. That is our troposphere. A little down about 10,000 kilometers away, about 22 kilometers away, that thin little thing is all our Earth is. All our love is confined in that. That threat, that little thing is what is Earth for us. And that Earth is faced with this challenge. And you know how population has changed today. It has just become this far. The past 12,000 years of population is what is put here. Just in the past 250 years, we have simply exploded. And that explosion, if you really trace back, you see that explosion has started somewhere around 1400, 1500. And you know, this 1500 is something, a very important magical year for science. Because this is when Galileo did his very early experiments. Galileo is said to have done this fantastic Pisa Tower experiment during 1589 to 92. Well, historians have traced it precisely to 1591 today. And subsequently, many things have happened. Many things that have happened, the central theme is that science has transformed the world. In 1947, our life expectancy in India was 32. Today, it is 70.2. And this has happened because of science. We produce 300 million tons of grains today, 120 million tons of rice today, about 100 million tons of wheat today, and about 30 million tons of bajra today. All that is because of science. And that globally has contributed to this. Because this is not the only thing that has contributed, many, many other things that have contributed. But what is the threat because of that? The threat is because if you start looking at the world as a whole for the past 1200 years, you see that it is roughly constant in temperature. The fluctuation in the temperature was just 0.4 degrees centigrade. This is combining the whole lot of data of 2020. A number of experiments have been done. Today we have ice core data from so many places, and we know I know one person who drills 1,200 meters down and collects ice core. So we have this data, and this we know is fluctuating only a little bit. And you know, this little small fluctuation, well, the only fluctuation is only within this, is the reason why we have agriculture. The only reason we have agriculture is because we have a stable climate. It is with that stable climate we can grow. We can ensure that there is production. We can ensure that there is tomorrow, if you let us say seed something today, you will have after 94 or 95 days later, you will have this much of kilograms of rice because of that. And this stable period, just after that, of course, as you can see, you get into ice ages and so many other fluctuations that you have. Temperature goes haywire. This, of course, also has been traced to 120,000 years now. So this period is the reason. But that period, what you see, this period is climbing up in the past nearly 15, 20, 30 years. Things have started changing enormously. But this prediction today is that it would go even up to about 4 degrees centigrade, which would mean that several places the temperature would go to 55 degrees centigrade. Certain other places it might go to minus 72, 75 degrees centigrade. So this is the tremendous threat the world is faced with. But then this threat has been there for some time in different contexts. People have said, well, it is not just people, IPCC, which won a Nobel Prize, said that the control over carbon emissions by developed countries is probably not the reason for the globe's survival, but the lack of development in less developed countries is. If the fellows who keep on producing carbon dioxide the way that they are producing, and all of us continue to produce, the world is producing, world is no more. What is the solution? And that is important because everything that we talk about is also deeply interconnected. To explain this deep interconnections, I took a picture of a very important structure, geometric structure called Borromean ring. I'm particularly interested in Borromean rings because in chemistry we make Borromean rings. What is this geometric structure? It tells you that one little cut that you make here, which may be a chemical bond, or it may be hydrogen bond, whatever structure, it may be a civil engineering structure. You cut this thing, all these structures will come out. Biology is great interconnection. Nature is great interconnection. For example, if you take this particular this glacier is from Iceland. This has been detached and it is now sinking. If a glacier comes out, of course, glaciers reflect a lot of light. And that is why glaciers don't melt. The temperature there goes down because most of the sunlight goes back. Now, if the glacier comes off, reflection reduces, heat increases, heat absorption increases, heat content increases, melting increases, sea level rise, biological diversity decrease, etc., etc., etc. And a person called Deepak Parekh will tell me, a banker will tell me, finally, banking will be affected. So there is a great interconnection between all of these. And this is the central point why the earlier point of whatever carbon dioxide rise or surface temperature rise is important. because of all that, people have talked about limits to growth. Limits to growth today is, well, it is an old book. It is a 1972 book. It has come out in three editions now. The second edition came out in about, I think it was 1992. This is in 2003 or so. Now, these have warned us about that. And some of you would like to read this book in greater detail. The principal point is, I told you about the population explosion. But population explosion, if you take a simple geometric progression, 1 becomes 2, 2 becomes 4, 4 becomes 8 and all, it just takes 34 generations to go to a population of 1 billion. And it went to this population today. Well, earlier it did not go to this population. Well, if it had, it was possible to grow geometric population, to have geometric progressions like this. In 850 years, you would have reached 1 billion. It did not. Because of pandemics, because of A, B, C, D things that we have, and because of the molecules we made. Molecules which protected us. And I'll come to that. Because of that, we have this, and if we continue to do like this, there is this prediction in the next 20 years, our human life expectancy will go to 120 years. There is no place for us. And I told you, molecules protected us. And I'm writing, being a chemist, it is important to be, loyal to my community. I can equally write this particular thing with something else in physics or civil engineering. Reactions that change the world. The first reaction is photosynthesis. And we understood photosynthesis in great detail. The second reaction is the one that gave us this 300 million tons of food grains. That's the ammonia. And that is the Haber-Bosch process that we have. The third one is the synthesis of ammonia, the synthesis of urea. Starting from 1828, when Wohler synthesized urea, that was the first chemical synthesis. But today we have made 9 million compounds. 9 million compounds. 8 million organic compounds and 1 million inorganic compounds. The fourth one is a combustion reaction. I simplified the combustion, but that combustion, if you were to do with hydrocarbons, that combustion is what is industrial revolution is. We have great understanding of this. The fifth one is polyethylene, and because of which we can now transport oil. We can now transport water. This IIT Tirupati wastewater line is because of polyethylene. We can do it at that cost because of polyethylene. We have polymerase chain reaction. We have electrochemistry, therefore you have your batteries and cell phones, and a number of such things. So reactions change the world. Of course, reactions also destroyed the world. Before that, I should also tell you certain molecules change the world. Aspirin changed the world, urea or morphine or penicillin or vitamin B12 or Taxol and quinine, and all of these change the world, and a whole lot of others. And without Taxol, we wouldn't have cured cancers. Right? Without quinine, we wouldn't have cured malaria. Without urea, we wouldn't have produced rice, etc. But at the same time, with great intent, good intentions, we made a number of molecules which it also destroyed. CFCs, it's a classic example. The ozone hole depletion, DDT, Agent Orange, what we were talking about Vietnam, and this whole destruction in Vietnam is Agent Orange. Endosulfan, thalidomide-based problems in birth defects and all that, A number of molecules which change the world also destroy the world. But in that process, Hey, look at this kind of molecules that we have made. This is vitamin B12. And this vitamin B12 was made by a few people, principally by this person. So who is this person? This person is Woodward. So Woodward is the person who synthesized molecules of this kind, complexity. You know how many PhD theses is this particular synthesis? This is 9 PhD theses and 6 PhD theses in another laboratory. So today you can look at this, how complexity is by synthesis. And today, any molecule that you give, people are ready to synthesize. And it is not possible to synthesize all these because of structures, because of great understanding. This person, Mendeleev, had this periodic table, and today that periodic table is the heritage of the planet. It is the heritage of the planet. If you are talking about global science for global well-being, without this table, we can't change that. So this is 63 elements Mendeleev put in table, but today we have 120 elements, including organised. So that is in 2002. Today, with these molecules, we have, without these elements, we have these 9 million molecules. But it's also important to understand or realize that it is molecules which transform the world, molecules cure the world, molecules are the reason for diseases. And this came from this person who won 2 Nobel Prizes. So this is Linus Pauling. This very fantastic, celebrated paper, sickle cell anemia, a molecular disease, he said in 1949. Diseases are molecules, therefore cure is molecules. The entire pharmaceutical chemistry, the subject area of great industrial revolution in this area happened because of this paper. Of course, this paper subsequently, you know, just after this paper, DNA structure came into being. And that contributed immensely to understanding. Being here, being in a technological institution, we should say that global science or global well-being happened also because of instrumentation. Because we could probe matter into greater detail. And I took one example to tell you that today instrumentation has become so complicated, extremely detailed. You can really go into greatest details. This is, you have 46 iron atoms put together in the form of this structure called quantum coral. What you are seeing is a confinement of electrons. And these are like bullets that are standing there. These are artifacts, but really they are atoms. These atoms, I went to this man's lab long ago. He's no more, Igler. Today, atoms can be organized in many different ways. We call this nanotechnology. It's also possible to see structures today with tomography. A small particle like this, with an instrument like that, we can see it in great detail. It is not only that in great detail, if you have a structure with neodymium and manganese, you can individually pick a neodymium atom and a manganese atom. To that precision, we can do imaging today. Of course, this is all possible because of another great thing that has happened in the world called internet. So the world ticked because of internet. I was just telling TSN that I won a prize. The largest prize of this particular one, the prize that I won, which is called the Win Future Prize, a big prize it is, it's $500,000, but somebody else got $3 million. And that award was for the discovery of internet, the World Wide Web. And this made it possible for today, during COVID, for us to live, for us to go and buy Swiggy made it possible for us to do banking, to do teaching. Everything became possible because of internet. And today we are talking because of that, right? And this great revolution of science has also made it possible for us to understand that there is this continuum of sciences. Nature, if you understand in greater detail, it is this structure, and that is today is bioengineering, and that is life, and that is today predictable. One can model it, one can create all these structures with instrumentation, and you can find molecular remedies, synthesize them and all that. Tomorrow, by understanding structures, you will understand the diseases. Understanding diseases will allow us, or these molecules will allow us to predict the new kinds of methodologies to synthesize them, to put factories for them. So it's a continuous chain of innovations can happen because we have global science for that global well-being. I'm going to get into, from this large canvas, where do we go? I'm just going to spend some time on that. You know, we had this big change in temperature, big change in carbon dioxide, just because we opened the cycle. What is that cycle? The world as a whole is nothing but this cycle. This green cycle is what is happening outside, which is done by sun, run by photosynthesis, water plus carbon dioxide, making you sugar and oxygen. This is what that great cycle is, which allows civilization to thrive, for us to eat and sit here. The reverse is what we do. In the process of our living, we convert sugar plus oxygen, make water and carbon dioxide as we breathe. Of course, this is a very simplistic diagram. Many other things we make. For example, we are not only making sugar and oxygen, we make alkaloids and terpenes and fats and many others. We are also burning many others and producing sulfur dioxide and nitric oxide and many others. So a whole lot of chemistry is happening, but major thing is this. But for us to live, we need to only burn this much of 29 billion tons of CO2. But what are we actually producing? We produce 258 billion tons of CO2. So this is the principal mismatch with which the world is faced with the challenge. So because of that, you produce a lot more of these. Because of all that, the amount of CO2 that we can actually have on this planet, we have exceeded too much. As a result, we have gone beyond our planet's limits that it can absorb. This is put in a diagram like this, called planetary boundaries. The planet is said to have 9 boundaries. So imagine this is a boundary within which the concentrations of the species and all that should be contained for us to live comfortably. That is the green boundary that we have. The red is the limit to which we can go, but if we go beyond that limit, the planet will not be stable. You can come back. If your limits have gone within that, you can, by methods, we can bring it back. So this is controllable limits. Beyond that is uncontrollable. And you know, in several of these planetary boundaries, we have gone far beyond. Now, what has happened is, in one particular region, if you have gone even far beyond, by measures, you can bring it back. For example, in the stratospheric ozone depletion, we went above the limits, but in 1990, but by controlled measures of CFCs and all that, we are brought down to the limits. It is possible by doing science well, by knowing it well, controlling it well, you can bring down the planetary boundaries. But in several others, you can't read it from a distance. There is a biogeochemical cycles, ocean acidification, freshwater use, and biodiversity, and a number of different themes. Some of them we have gone far beyond limits. And this I don't have time to tell you this. If you have to be within planetary boundaries, we have to ensure that the materials that we consume, such as the batteries that we have and things of this kind, we have to know how to make them with materials which are sustainable. Biology made this whole complexity just because of 5 elements. Most of it is carbon, hydrogen, oxygen, nitrogen, phosphorus, you know. Little bit of iron, little bit of a few other things. But the periodic table is essentially, most of it is untouched. You look at the complexity that we have. Yesterday's coffee that I had from this shop to 40 years ago, whatever I ate, I can recall all that. This is this huge biological complexity that we have produced with just 5, 6 elements. Is it not possible for us to make a battery with these elements? Is it not possible for us to think about creating new fibers with these? Is it not possible to think of new plastics with these? So that took us to research. We made clean water products. And this is one such thing. What you see, this is a product that you see, which is cleaning arsenic from water. Well, we have now given about arsenic-free water to 1.3 million people every day using these technologies. Basis of this, those of you who are young will not understand this, but essentially we do some work in the lab and we publish a paper. This is what we do. And this paper essentially talks about creating some materials. You pass some dirty water through, the material that we produce are highly porous and it will remove selectively arsenic from water. Shihab does similar work here. So you create such filters. This is a laboratory filter. You put certain amount of arsenic in water, some number called for 200. It is saying 200 micrograms of arsenic is put in 1 liter of water. There's some number. This is a very toxic concentration. You reduce it by passing it through to get it to 2 micrograms. And what you can do is now you can make this into quantities. You can make a filter for schools. You can make a filter for homes. You can make a filter for a city. And then you can do it in larger quantities, in 1 million liters, 2 million liters. And you can now put it across the country and you can go all over. And this is something which can be put with sensors, a lot of sensors. And with that, let me tell you what we did. Here is, can you just play this? Here it is.
The state of Punjab. We took a drive right into its heart and soul, deep into the interior villages. We were dumbstruck by the beauty of the green fields. All through our journey, we had noticed several blue-colored equipment in white cages right below water tanks. We explored. We learned that these are community water purifiers installed at 97 locations across Punjab in capacities ranging from 25 KLD to 1000 KLD. Based on state-of-the-art nanotechnology, it removes iron and arsenic from water without electricity. It delivers pure water conforming to all quality standards at an insignificant cost of 2.5 paise per liter. We tasted this water, and let me tell you, it tasted so pure. This water purifier, incidentally, is called Amrit, meaning nectar in English. The groundwater in the state of Punjab is highly contaminated with iron and the deadly arsenic. Exposure to arsenic from drinking water causes heart diseases, diabetes, and may even cause death by cancer.
कैसा है पानी?
बहुत मीठा है।
Obviously, nectar is indeed sweet. We resumed our journey, traveling through rugged roads.
You can take the crystal clear one.
मेरे स्कूल के साथ ही वाटर सप्लाई की टैंकी है। इससे पहले जब ये प्यूरिफिकेशन नहीं लगा था तो बहुत बच्चे बीमार होते थे। बच्चे वाटर बोतल घर से लेकर आते थे।
There are no diseases at all and ਸਾਰੇ ਬਹੁਤ ਹੀ ਵਧੀਆ ਨੇ। ਹੁਣ ਵਾਟਰ ਬੋਟਲਸ ਦੀ ਵੀ ਕੋਈ ਜ਼ਰੂਰਤ ਨਹੀਂ ਪੈ ਰਹੀ।
8 ਵਜੇ ਤੱਕ ਪਾਣੀ ਆਉਂਦਾ, ਬਹੁਤ ਵਧੀਆ ਪਾਣੀ।
ਡੰਗਰ ਵੀ ਪੀਂਦੇ ਨੇ, ਬੰਦੇ ਪੀਂਦੇ ਨੇ, ਜਾਨਵਰ ਵੀ ਪੀਂਦੇ ਨੇ, ਬਹੁਤ ਵਧੀਆ ਸੁਸਰਾ ਪਾਣੀ ਜਾਂਦਾ।
तो सारे बच्चे और हम स्टाफ भी खुद भी वही पानी पी रहे हैं और वो पानी काफी अच्छा है।
अपने घर के लिए लेकर जा रहा हूँ, तो फिर पाइपलाइन बची हुई रहेगी पानी में। अभी रिपोर्ट भी कर ली बहुत, तो 2 टाइम लेकर जाते हैं।
People were emotional when they spoke about how these water purification plants had brought in drastic improvement in their lives and health.
मैं ਤੁਹਾਡੇ ਕੋਲ ਕੁਝ ਮੰਗ ਸਕਨੀ ਆ?
ਹਾਂਜੀ।
ਅਗਰ ਕਿਸੇ ਦਿਨ ਤੁਸੀਂ ਇਸ ਪ੍ਰੋਫੈਸਰ ਪ੍ਰਦੀਪ ਜੀ ਨੂੰ ਮਿਲੋ, ਉਹਨਾਂ ਨੂੰ ਕਹਿਣਾ ਮੈਂ ਉਹਨਾਂ ਨੂੰ ਬਹੁਤ ਅਸੀਸਾਂ ਦੇਣੀਆਂ ਕਿ 100 ਸਾਲ ਜੀਣ। ਉਹਨਾਂ ਨੇ ਵੈਸੇ ਵੀ ਆਪਣੇ ਅਗਲੇ 10 ਜਨਮਾਂ ਵਾਸਤੇ ਬਥੇਰੀਆਂ ਅਸੀਸਾਂ।
I didn't know this is something that somebody is speaking. Oh my God.
The periodic water quality test reports showed us that the amount of arsenic in water is untraceable. It exceeded WHO specifications. The plants are cleaned once every 15 days through a process called backwash. When the nanomaterials which absorb the impurities reach saturation capacity, the active materials are replaced. They are safely discharged and the state has arranged for this. Our joy at encountering a mountainous stretch on the way to Roper forced us to halt for a cup of hot spicy tea. Surprise! We saw the familiar water tank at the top of the tallest hillock in the area. We were inquisitive.
हमारे गांव वालों को इतना अच्छा फिल्टर से भी अच्छा पानी मिला है, सब पानी आरओ से भी बढ़िया है।
We then visited the largest plant in operation so far at a village called Chaudhariwala. Here was a 1000 KLD plant delivering clean water to about 650 households to almost 4,000 people, 70 liters per day per person. We were impressed. This set us thinking, if over 97 plants could be integrated along with water supply schemes, the government must be hyperactive too. We reached Chandigarh to talk to them.
बहुत अच्छी योजनाएं चल रही हैं ताकि लोगों को अच्छी क्वालिटी का पीने का मेटल रहित पर जो पानी है मुहैया कराया जाता है और उसको कंट्रोल करने के लिए IoT योजना के जरिए उसको हम कंट्रोल कर रहे हैं और उसकी गुणवत्ता को चेक कर रहे हैं।
I am very thankful to the IIT Madras, whereby they have provided a technological solution where the heavy metals like iron, like arsenic and others can be removed from the drinking water.
What was good was that the IIT was also willing to work with us on changing the prototype that we had. And they came out with a prototype of what is called the household arsenic and iron removal purifiers.
Technology was based upon the nanomaterial and it was a highly efficient technology, which is adsorption based nanomaterials are used for cleaning the water.
So intangible benefit of these things in the terms of health, that's a direct impact as an economic value over the life of the people.
These plants are quite compact with high arsenic removal efficiency as nanomaterials provide larger surface area.
We understood that the common man-centric government is very proactive and keen to expand on what has already been done. That was enough. 17 days driving. We took a flight to Chennai to further quench our thirst for knowledge. IIT Madras, the best engineering institute in India for 7 years in a row, beckons us. The seat of life-transforming research. As we hang around to meet Professor Pradeep, a Padma Shri awardee, we take a glimpse of his laboratories. Science done here gets transformed to startups and products such as Amrit with the help of IIT Madras Research Park, the first university-owned research park in the country. All of a sudden, someone ushered us in.
It is now clear that we can address all contaminants of relevance in drinking water affordably and sustainably in India and anywhere else in the world. Although the models shown here are for arsenic and iron, we have similar models available for fluoride, uranium, chromium, mercury, and others.
As we walk out of Professor Pradeep's office, we are in awe. Science, nanotechnology, infinitely transforming people's lives with water.
What I wanted to tell you was this was somebody who went to the field without my instruction because they heard that something is happening. They took a video on their own. This will be released on 28th. That is a few days from now by IIT Madras Alumni Association. So the basis of this is a few units. There are 1,700 units of this kind in the country today. Now, what this means is that sustainable solutions, this incidentally is made with biomaterials. And they are actually made by fixing carbon, right? Biological thing is by fixing carbon. So you are actually contributing to no carbon. So this is a carbon sequestration methodology. Now, there are many other similar technologies that one can work with. But where is the world leading to? 2 more minutes to go to say that as young children, where do you invest your time? There are, of course, many things that you can invest into. I picked up 1 or 2 examples from here because the time is short. The world is nothing but CO2 plus water. I told you that it is photosynthesis and things like that. Is it possible to do a full cycle? Meaning you make CO2 and in that process you make carbohydrates, whatever, but you produce CO2, right? You produce CO2 at the end. Is it possible that this CO2 can make a methane? That is what we call C1. Can you make CN? C6 will be hexane. What it means is that this process of CO2 to methanol or ethanol or hexanol or hexane, all of these are reduction processes today. They can be run by sunlight. And in the country today, we have one person making 2,000 liters of methanol a day from CO2. It is possible that you will tomorrow hear about that methanol. Today, it is not economically cost effective. It is at 42 rupees, but economically, you need to make it at 36 rupees. But today, there is a problem. It is possible that hydrogen can be produced today. And on this, the entire civilization can run, but it is not cost effective today. Many people think that 150 rupees of hydrogen can be made to 30 rupees in 4 or 5 years. Well, there are many things related to that. Satya is running this campus, right? Is it possible that one day we will pull carbon dioxide from air and then run our chemistry labs with that so that nobody will buy methanol? Not just methanol, there will not be anything coming into the campus. Maybe this is possible. Technologies are in pipeline, and maybe when some of you do PhD, you will be running PhD in a laboratory which will actually suck CO2 and give you methanol. Or maybe ethanol, which we will use in the evening. Or we may have, I told you, I wanted to tell you that, go a little bit back to tell you that today there are spectrometers of this kind. 4 millimeter spectrometers. And they will go onto mobile phones so that we can measure water quality. We have these, but they are a little bit larger today. But if you were to make this 2 millimeters, your Apple phone will have a spectrometer. With that spectrometer, not just water quality alone, many other quality will be measured with food and agriculture and all that. It is also possible today already we have health monitoring devices of this kind, but these health monitoring devices are already coming in. This is a 2018 paper. It's already coming to the market today. And it is possible that food is produced in the laboratory. This is my own laboratory result to say that we can actually make a biscuit from CO2. I'm sure that you will make something else tomorrow. This is not something that you will eat. It is not looking like biscuit, but there are friends of ours who are making meat in the laboratory. Food is possible indeed from CO2. And that's a small piece of biscuit. If you are coming to my laboratory, you will get this. This research is done by people like you, people who transform the world in institutions which have infinite, boundless energy. Thank you very much. I don't know.
Thank you so much, sir, for your enlightening words. I'm sure your erudition has truly inspired all of us gathered here today. Now, I would request our esteemed director, Professor K. Satyanarayana, to felicitate the honorable guest of the day, Padma Shri Professor T. Pradeep. Sir, please.
All of you going to the Apple? This is the Calgary art that they make. They are especially commissioned with the party.
Thank you, sir. Now, I would like to invite Dr. Shihabuddin M. Malekal to deliver the vote of thanks. Sir.
Thank you, Professor T. Pradeep, for an enlightening and inspiring talk. You have shown the path to all of us, what an Indian scientist can, achieve in a short period, and how a scientist can give back to the society. The research findings should go beyond the laboratory and should reach the needy in the right, in the correct form. So thank you very much for showing the right path and inspiring all of us. Thank you very much. And audience may not know this. Sure. The audience may not know this. Saturdays are always close to Professor Pradeep, and he usually avoids external programs on Saturdays. This is not because it is a weekend or holiday. This is because he conducts his research group meeting on Saturdays. And thank you very much, Professor, for accepting our invitation and being here on Saturday. Thank you very much. And I also thank all the participants who came from different parts of the country and joined us today. Thank you. So if you have any questions, I request Professor Pradeep to address the questions. Yeah.
Go ahead, please.
particularly students. Do you have any query? Anyone? Students from Arunachal, you have anything in your mind? Yeah, please.
Thank you, sir. Sir, I have a question for last, sir have shown that carbon biscuit he has made. My question is that how it is carbon will not harmful for our health, that carbon biscuit you have made, no?
That was not carbon biscuit. It's a biscuit. Well, carbon dioxide is absorbed from air.
Yeah.
And the organisms inside that biscuit convert this carbon dioxide to carbohydrate. And of course, they also make proteins and many others inside that. And so this is food, basically. Carbon dioxide is not, which you produce.
Yeah.
When you consume, you produce in breathing, you produce carbon dioxide. Okay.
Okay. Thank you, sir.
Right. How efficiently you convert carbon dioxide to sugar? How can you convert it particularly to proteins? Can you make harmless, let us say, some additional things? Can you make nutraceuticals? Many other related questions are there, which we pursue and others pursue as well. You have? Okay, go ahead, please.
Thank you, sir. Sir, have you been to space? Sir, have you been to space?
I have not been to space. No, I have not been.
Oh, thank you, sir.
Yeah.
Sir, you have been said so many things about the science, but I have one doubt. Will you believe in our tradition or in science, sir?
It is science. I talked about science, and it doesn't mean that I don't believe in traditions. Science and traditions are not diametrically opposite. I do not believe that. However, today I talked about science. If you want me to talk about traditions, that's another lecture. The bottom line is that they are not opposite to each other. I built on science because all that we have today to fall back on this great global challenge is science. Thanks.
Any others? Yes. Sir.
Sir, thank you for that lecture. So probably the young minds will take this further. So to take this further, we need creative ideas, sir. That's going to, that will only take this further. So as the students were asking whether the biscuit can be consumed. Right now, it's not. Possibly down the line, probably we will be able to consume it. So what is your take, sir? Creativity comes by persistence or luck?
Over long years of work in science, of course, you understand a whole lot about science. This knowledge is important. Your basic understanding is important. That's why you go to schools, colleges, whatever. But ideas roll down. Today, as I am standing here, I can give you ideas for 10 PhDs right here. Ideas roll down. That is because of your preparation. You are standing, I keep telling my students that you can't shake me because my foot is very strong. So that is very important. Ideas do roll down to such people. You need to prepare yourself. Now, ideas by themselves don't change the world. You need to have perseverance, persistence. 1,000 things fail, only one thing works. So therefore, you need to continue to devote your attention. What comes first? Many people think that perspiration is more important than imagination. Yes, it's a combination of both. In this work or any other work that I have done, it is together, perspiration and inspiration. Both are important.
Okay, so thank you, Professor Pradeep. It seems there is no other question, so let us thank Professor Pradeep again. Ranjan.
I would like to thank our esteemed director, Dr. Satyanarayana, Professor T. Natarajan, Padma Shri Dr. T. Pradeep for honoring the occasion with their presence. I think Dean SRC, Dr. Ian Kumar, Dr. Shihabuddin M. Maliakal, and Dr. Saurabh Chakravarti for their kind words. Thanks are also due to Dr. Vaneet Kashyap and Dr. Debashish Mondal and their team for their phenomenal work. Many thanks to the teachers from Kendriya Vidyalaya and Bharati Vidya Bhavan for their valued contribution. And thanks to the CC team for the arrangements. And lastly, thanks to all of you for being such great audience. Thank you.
Now, I would request the contingency of Ek Bharat Shresht Bharat to stay back here for your orientation program. As for the school students, Ms. Chandni will accompany you for a beautiful campus tour.
Thank you.